So I have to manually click that so I can mute and unmute it. So anyways, hello, it's currently 12 p.m. in the Philippines. So, as you can see, there's a lot of drastic changes. You can define, oh wait, I forgot to add that here. Oop. Oh, I should, yep, define error. So, yeah, that's a lot of code, right? It's just match statements, don't worry. So, this, right, yeah, you know what, let's put this in a function, I pressed the right button, there we go. So that's parameters, and boom, here. Now here, instead of jat, what's jat? I'm just gonna go match error, then you're just gonna give it the error. So as you can see, there's new instructions too. So yeah, go. It still works. Good. As you can see, nice error. Wow. So if we define another, define error, other error that way. So and then we have, for example, change this to other error. As you can see, it works. Unknown error 12, other error. But yeah, as you can see here, there's a much statement. So I'll quickly explain what these much statements do. So a case accepts a condition, right? This is evaluated on runtime, not just with a case. So you can run this everywhere. So for example, you can go here and put 1 there, it will evaluate true. Why is that string? Just a second. So this we should. Oh, you've got to be kidding me. No, we're gonna stop. Okay, yeah, string quoted. Yeah, this. So we just need to. Why is it not working? That's weird. Huh. This is oops, wrong key bind. Wrong key. There we go. Save that. Oh no, no. Wow, stop. Alright, so that should temporarily. What the hell is wrong with the numbers? You know, let's this. Maybe we just need to put it at the top. I hope it works. There we go, it does. We need to fake how. No. Serial problem. Here, not just columns, but oh, let's go too far, but dots as well. So there we go, that works. Is it because it's inside a bracket? Yeah, it is, because it's inside a bracket. Why is that different? What if we do this? Does it change? Nope, doesn't change anything. So why does that happen? Weird, very weird. Seriously? What? So if you... No. But why? What? So if you're telling me that I need multiple... Oh, it's that. We did not do that. Do that. How about now? Well, What? What? Sorry, what? Why is that not working? So it's a daughter number. This. I need. Why? Oh, and I don't know where. I don't. Why is regex like this? Why is regex like this? Just listen. So finally, I found that. So that's all I needed to do. I guess rewrite it like this. So now here, case one. Yeah, so see it. Just go success because this is always true. But if I go with, it's an equality operator. That's why here it's with 69. So you don't need to go like case, and then error, then one, or manually check it. Like for example, here 69. You don't need that. You don't need that. So you just go case with. So now match with. So that's why it's a match with. It matches this with this. Match error with 0. Now match a case. Yan, nandito na kami. My grandmother here is just registered for the election, I think. Well, I don't know where the what registration it's they just said they registered something. Anyways, so I might need to mute my mic soon. So anyways, where was I? Yeah. So here, match with a case where error is less than the length of meta-error built-ins. This is a list of the defined built-in errors here. Well, defined errors is where we define the built-in errors with the you know how to you probably know how to code because you're watching my channel anyways. So yeah, that, and then if it's a built-in, it's probably a built-in error, you know, and of course this one nice error and stuff like that. So yeah, and then these unknown errors is if we don't match with any of them, and these default blocks, they will always run when encountered. So for example, if I have two default blocks, it will run the first one, only the first one. It will, when it encounters a default block, it runs it and then it exits the match statement. That's it. And we also have fall throughs. So for example, we want to print success. Well, wait, no, we want this to match, but also fall through with this 69 block. We can just go fall through, and then it will fall through. Oh, it's because, oh yeah. Oh, and you can't use fall throughs with default blocks. Once they run, even if you call fall through, the next block won't execute. Just so you know. So here, for example, we have this kind of error. So built-in error like a runtime error. Oh wow, yeah. Oh, go. See, it runs both the built-in error and then the nice error thing. So yeah, and also prints the error ID. So yeah, and we don't. It's not recommended to define their ID, but if you do want to, then you can. Example, was it 315 or 314? The teapot error. That's for 3 something 415. I think it was. So anyways, example we have this and put it there. Yeah, we have that unknown error teapot. For example, we can add a new case or with a statement where it says 415. Then here we can go do this. Oops. And then teapot. There we go. Teapot. So anyways, yeah, that's how match statements work, and we have a new expression syntax. Both parentheses and square brackets are expressions now. So we can't just like go here and then item one. No. We need new syntax that, and then you type in the items. Yeah. So even if it works, alright, it works, and yes, it will make the code more noisy, but it's much more better that way because it's explicit, especially if you want a tuple, you go on that. Why did I lose that? So you have a tuple of items with a D in them. So we have that, and this sum operator will convert non-string values into the first first items type. I did not know what I have said. So this, it means that if the first item is a string, then everything after it will get converted to a string, right? So like if I have this is an integer, right? You can just add it to us. You can't just concatenate it to a string. We need to convert it to a string first. Then if it's all numbers, then it will get converted to numbers. So for example, if I have like example an item, for example 90, and then the next number is a string of 90, it will print 180. And then if this is a string, and this is not a string, it will become a string. So 9090. It's not some, it's not some JavaScript bullcrap where everything just whoosh, it becomes object anyways. So we have a lot of constants: true, false, nil, none, and this. This is, wait a second, that's not what this I like. That's weird. Can I like do this? Nope. Nope. Um, there we go. So we just, I guess we can just go do this, is this. What happened? There we go. So now we have that, right? So this is an ellipsis, just like in Python. So yeah, we have that. So an ellipsis can be used as a line. For example, we have function test. If we want an empty line, but you also want it to be, optimized away in some case, yeah, you see function test is empty, or line 49, this one. So because this gets actually removed, but it also works as an expression. So we now have an ellipsis as a parameter type. Parameter. Damn it. So if we don't want the function to be optimized away, we use pass. And the difference between those two is this is, you want to implicitly want that line to be optimized away, where pass, you want the function to be defined still. The only downside is pass takes up precious, very valuable runtime execution, runtime, while this is pre-runtime, processed on pre-runtime. But the argument, who the ellipsis as an argument is processed on runtime. Yeah, that. But when we need we need to is static, so we can go, static code. So now here we can go if so yeah, for I in code, if is instance I list, we go, oh, if not is static, I return false. Otherwise, in here we're gonna go, and if is fi, isn't it like, oh, is var and fvar, is var I, or is var fvar I return false. Even if it's just an identifier, it will return as false. Otherwise, we return as true. So now we should go add a rin. So now here we can go print if a block is static or not. Control S static dot glue, not glue, dot DPL. So now here pass. So this should be static because it's a string. Same as this, same as this. Negative or not, that should be static, right? So let's print it. So here, before we go, I'm gonna go print arg proc is static args. We should put that close to there. So, ooh, in terms of pi here. So, the problem is, I just need to go. If not is instance, come on, a string, we immediately, you know, just before this we go. So now that should be true, but as soon as I add like test, should be false. There you go. So that's static. And the problem is, yeah, because we need to check it. So yeah, so if it is static, that means we can, interpret it and not have consequences. So like, we can go process argset and we know that it won't need any runtime value at all. So like, problem is how will we implement that? So now here, this is where we're going to do that. So static args, so that should print that, so it's true. So now here it means we can go process args on it. We do have frame, right? We do have a frame, yeah, end frame. Where is it defined? On top? Yeah, there's end frame. So now here we can go arg proc dot process args, then we can go ORM end frame, then args. That's that. So if you go list, as you can see that, and this should be nil on ellipses. Yeah, it works. So we do that. So now here, if arg proc dot static is static args, we go args is equal to arg proc dot process args frame. So since we know that that's static, it's evaluated pre-runtime, so that's pretty cool, isn't it? So this should almost, no, not almost, it's instant, because, you know what, 21, yeah, microseconds, but if we remove this line, that means we would have to interpret it, on runtime, which, look at that, it added 4 microseconds. Even if it's not small, it's still very consequential to large programs. We need to shave off every run, everything that we can off. So, plus we wouldn't need a runtime to run that, and when we compile scripts that has a lot of static code, like that, for example, like setting some variables, like adding some strings, we can, we can we just need to make them static. static. We need to evaluate in pre-runtime, and that's pretty cool. Yeah. So the only thing I need to add for optimization, example, yeah, we look through through sample. So for example, we don't do anything with that, but we have a pass in there, and what we do, or for example, we just go do that, like go pass, but we do use that value. For example, char c. I should implement an optimizer to check for this kind of stuff, so that we can just remove this, right? And all we need to do is literally just index it. Test -1. Yes, that does work. Oh no. Straight. Oh, wait. So negative numbers don't exist anymore because of that. Oh no. Need to remove that. So now we should be able to go -90, if not have. Okay, so we have -1. Boom. There we go. We got the last letter. That's it. So yeah. Oh, by the way, that's the new indexing syntax. You give the object that you can index to iterable, like lists, strings, and dictionaries. So for example, if this is a key, then it would work. So for example, like if you go set this to a dictionary, and then we set this dot name to, for example, my name, and then now we can go print ln, and then in here we can go this and then name, and then it will print out that. Yeah. So yeah, it's pretty good, pretty clean shorthand syntax. I know it looks Lisp-like. The only problem now is that we can't have multi-line expressions. Yeah, we can't have multi-line expressions. So yeah, we can't do anything about that. And I don't know how to implement, this kind of stuff. I'm not that good, alright? It's just the man who built the goddamn program language. So anyways, we have that. And now, since we have static, stuff now, the only thing we would need to check is, we need to do it recursively. Because, for example, yeah, we may have, like, for example, we call some method over here, and we pass in, like, a list. This can still be interpreted pre-runtime, right? So now here, yeah, we can go def static to static code. Now here we can go for I in code, for example. Yeah, we're just gonna go yank this code into here. So we have that. So here, so we have this. If not static, if it is static though, then we can go code I. Code I is equal to um, static code, and then I. So yeah, that's it. That's the code. So we enumerate a list of tokens, and we check if it's to static. So now here, instead of where is it? Here it is. So now here we just go args is equal to arg proc dot to static. They should still run. we forgot to return stuff. So here is, oh, what the hell? Whoa, 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 whoa. So now here that should work. Oh, okay. So why would that be? Wait a second, that's static. One didn't. Oh, no, 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 that is static. The problem is tripping that. So now that should work. Hmm. Ah, that's my problem. There goes my problem. Oh, no, uh, here static. Put it there. Arguments. We have this load. Here's the indexing and the method calling. This should. What could be the best example? Just put some line arguments as well. Just add this to special separators. These special separators will separate identifiers and insert that identifier between that character between. And these normal separators separate the code but do not inject themselves into those cracks. So you can see that like test add test after I remove this. So as you can see, but if you go test that test including spaces, so as you can see there's no comma whatsoever, it just separates the identifiers. So yeah. So now here where were we? Yeah. So like for example you can now go at method and then make a list of 390s. So we got nil. So problem is this is not a method. Like but if we do that, we could probably have a shorthand thing for a list. So just return mission logs. That's it. So a shorthand syntax for a list. Oh, okay, so static DPL. And that means here is to static. That should be plus. There we go. So now listen int because as a string static arguments. Now here we will put this code above the string indexing. Same for this. Whoops, wrong button. So an attribute type list. If int is oh no. We need to. You know what? Yeah, we don't need this shorthand syntax for lists. We are strong. In nil, we get nil, of course. But if we go like, for example, list, so we will have a list and a list and a list. As you can see, I just need to go here. It's above any static, so we just can go print code pause. So here we will go analyze it. So this static list should become this. And then this list becomes that, but it didn't work. Why? To static. Oh, oh. is static. You can go. You can go evaluate it. No. You can go get the from what we can do. Yeah, is this X per runtime basically. No, we can't because we need to evaluate it. Evaluate. Well, that works. Well, yeah, of course that should work. So yeah, now we shave off even more time. So for example, um, so we have 50. Why is it a nil? Oh no! Oh no! Oh, that's bad. I guess we because we need that methods. Like this ID, how does this ID work? This ID. Oh, too bad. I guess he can know because I if I starts with this or yeah yes if LFI to I0 in this, then it's probably a method and we return false. Anything in a method is false. LFI in some I got low some Lenov was it a pen? No, it's different. Lenov stuff like that. Len of type or in here you just return the expression. How about that? There you go. So we get 67 microseconds to that. 67, 45, 42. Okay, so it's just a cache thing. Oh, that's weird. So it's under 100 microseconds at least. So now let's disable that. Let's see how slow it can get with that. So it's in the microseconds range. Come on, where is it? There we go. And if we, remove that, yeah, it's still in the microseconds range, but it increased by at least 40 microseconds. As you can see, our valuable time is wasted. Oh, arguments. I bet I can get this even more. Um, we can go to static. Yeah, evaluate stuff. But that's just yeah, that's too. That's too. That's shallow. No. Hmm. Like yeah, that. So how about a list of a list of a list? That should be a large list. So, oops. There you go. That's a large list. 60 milliseconds. 70 microseconds, milliseconds, but boom. and now it's 98 microseconds. So yeah, I know it's a few microseconds, but still, who knows? A freaking psychopath might put this in their code base, you know, and increase it to 238 microseconds, even with that. 238, 238, and now look at that, it's 300 microseconds because of this abomination. But with this, it says 100 because it's just printing it. But if you go past, it's even more faster to 145 microseconds, as you see. But with this, yeah, it's 127 microseconds too. Wait, why is that? See, I might be doing this wrong. Am I doing this wrong? Yeah, let's use hyperfine. Let's use hyperfine. So we go cd into examples, hyphen example. Now here we go hyphen 3 DPL dot py run. This is static.dpl. So it should be microseconds. But here I'll go hyperfine. Was it? Yeah, there we go. Boom. So look at that. It's of course we're running it with the the runtime. So dash warm up dash warm up 10 runs dash 10 example 100 runs. And that the runtime already initiates slowly, because it's Python and stuff. So it's pretty crucial that we optimize the interpreter itself. Hence this example. So if we compile it, then yeah. So for example, here we can go add a control, uh, a dash dump file or a dump command. So here we can go case like we have compile here. So we just go control yank that code in here and dump comp. So we compile it and then we dump it. So instead of writing that, we just print it. What? Oh, it's oops. Did it again. There we go. So we have that. We don't need this. So there you go. We parser that process in file.read. So now we can go. I don't know why I did that. There we go. So as you can see, it's a lot. And as you can see, there's the code right there. And as you can see, in compile time, we haven't even run it yet. It's already evaluated the list. Where's the end of there? The list. That's the list, right? It's the list. But if we disable that, so for example, we comment that line again. Where's that? Okay, so there it is. We comment that line. Oh, that list. It's even more longer there. So as you can see, yeah, it's a lot of stuff, right? It's a lot of stuff. And instead of just fetching the number, the interpreter has to, reevaluate this on runtime. Look at how long that is. See? And or it's fewer lines to the that. And yeah, it's that good processor thing. It's the processor. Okay. So yeah, as you can see, it's pretty crucial. What's this? Anyways, so we need to there we go. So now, for example, that's why in some cases now we are sure that compilation will indeed speed things up. So now here, so we compile that. Now instead of going run, we go rc static.cdpl. I don't know why this always ends that, but yes, it. Oh, what? No, stop. What's the dash? There we go. So yeah, and 326. So if we use the non-compiled code, look at that, look at that, look at how much difference there is. Yes, the minimum is that, but look at the maximum, the max. It's 419.6 milliseconds, while this is 4.68. Oh, that's 50 milliseconds of difference. 20 look at that. Look at it. Yes, it may not be different, but look at the system time. 10 milliseconds may not be a huge difference, but in production stuff, yeah, it is. I know my program language is never going to reach that point, but still, whoops, when making a programming language, you need to consider everything. And yeah, and I'm proud that we can, we can check it. I can use I hate this problem. Really need to format my comments. What now? Oh, good. Why? Fine. Fine. Slash. Uh, oh, you're gonna be kidding me now. Yeah. Does he going to go again? Oh, yes. What? Oh, goodness. Oh, no. I hope that's right. Ah, there you go. Oh, come on now. There we go. What am I missing? So, oh my god. And then it's in core. That's What was that again? I forgot. I know there's. Oh no, it isn't started with safe thing. Yeah, there's an error. That's why it can't. Boom. Goodbye. I don't give a hell about you anymore. So there we go. So yeah. Config file. Yeah, configure. Check preview. Py what? Nope. Dash L, huh? Dash T Pi 3.10 at least. Yeah, this runs on Python 3.10.9. 3.10.9? Ah, yeah. Because of the match statements used. Yeah, it's pretty integral part of the code, and it helps a lot in parsing stuff. Just checking some stuff. Oh no, okay. Enable on dash diff. Oh, I should have done that. No, anyways. Oh, um. Oh, come on now, Windows. Of course. Yeah, that's good. Yeah, of course. GitHub no bash scripts git push 1.4.6 updates. Give me some stuff. Yeah, I know, I'm awfully quiet. Just for a second, I'm focusing. Oh, is that Fibonacci thing still, will it still work? Right. Fib. What? Yeah, oh, there it is. So here, yeah, a lot of stuff. Oh, by the way, this is slower because of stuff. So fib, yeah. Factorial, yeah, this is the one. There we go. After a program should be faster than outro. Like 11 seconds. Who knows? Who knows how long this will take? Oh, whoa, frame. Oh, oof. It's in. Oh, that's 7557. Oh, there it is. Down. Now we can go run that. Boom. That should memorization 2 seconds. Alright. No wonder why. Without memorization is just oof. Ooh. Okay, there it goes. 5 plus 780. Same problem. Now can we run it safely? Ha, you know that 2 seconds or 3 seconds, and then it's just 234 microseconds in the second pass. What the hell? What? Oh, and by the way, this required raising the recursion limit. Yeah, recursion limit. What is that thing doing? Wow, it's just damn, 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 son. Just damn. It's fast. That's why we have memorization, guys. The only problem is memory. That's the only problem with memorization, and it doesn't use a traditional cache like the just wait, most recently used value, right? It's on the top of the cache, but no, this uses a dictionary internally. It's just a dictionary, but it's fast. It's faster, right? And it's a quote unquote cache miss when you do this. But yeah, damn, it works. It works. Oh boy, it does work. And yes, we can print. We can print the cache, but it will not be good. So like if you go um memo memorize, come on, memorize fact, let's just go memo-wise. 1 second, and then there it is. It will print. Apparently nothing. What? Oh, did just. Oh yeah, I forgot I added that thing. Okay. So now we're just gonna. It's an error, isn't it? Or is it just that big that it's having difficulties printing it out? It is, isn't it? What? Oh. The hell? What the hell? So, example, we have this seeding tool example. Now we go Python 3 DPL dot run factorial DPL. So what happened? Make sure that it does run. There. So 3 seconds this time. So look at that, milliseconds this time. And then it just doesn't print them. That's how big it is, I guess. But if we lower it, so yeah. What? That's weird. What did I? Oh, it's okay. So instead we go 800, and then on this one 801, but should be smaller. And there it is. Yep, there it is. So yeah, that's it. And of course, we don't just use the parameters, we turn them into IDs, and then yeah, well, that's a pretty big number. So this is 801. It's been memoized now, and it's just, that's a huge number. What the hell? It's 100 milliseconds too. So anyways, yeah, we should not print that now. So now that you've seen that, should see the outs. And oh no, I missed the time. I was supposed to do something half an hour ago. Anyways, so there we go. Just close down. This doesn't. Oh, yeah, I forgot that did that. Sample. I don't know. It's in lib standard multiply, and it does that. Memorize. No, we don't know that now. We go items, and then memorize. So we don't just do that. What imports it as what? What? That's a new thing. What is that? Can we like I'm gonna unstretch it. Yeah, that's yeah. So, yeah, what is the build package for other than pickling functions? What? Wow. Oh, interpreter state. What? Hmm. What? No way. No way. Nuh-uh. Nuh-uh. Oh wait, that's a pretty good idea. I was cracking my butt. Cracking? Popping my butt. I don't know what the correct word is that. Uh, huh? Poop in bed. There we go. So we can implement it right now, right here, right then. Oh yeah, I forgot. I forgot that I can. Not there. In bed. No, that's one. So always that. This no that path. That is file. So now here we can go file. Oh wait, we need to add that now. Bytes. Come on now. There we go. That nil. Just wait a second. My grandmother's calling me. So yeah, just a second. I'll be doing something here. Zero now. Oops, file. Wait, is that safe? We are not using for anything, right? Yeah. Yep. So file, we go open it. Open file. No. As f. We're gonna go var proc.rset. Nah, we don't have that yet, so we're just gonna go frame -1 args 3, not 3 2 is equal to f.read. So otherwise we're gonna go return a error.pre-processing error, and then we're gonna go like file could not be found, file not found. So embed binary. So now here we use bytes. Wait, bytes. So now we have that. So now here we can go static.dpl set this list. This is evaluated at pre-runtime. This is evaluated at runtime. Does it work? Yep. Oh no, that's not working. Nande. Oh no, it's not here. Oh no, here it is. No, wait, no. What? Where is it? No, it's not here. So where? Oh. And what is this doing? Oh, it's just returning us that. Okay, so we actually need to go minus append. Uh, what? That's not what I expected as well. The index is after. Certainly this did not match. Yeah, it does append. It's a list. Of course. So you're telling me that this is not working. Nande. 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 So why? Why is that? It's just not gonna do anything. But why? Is it matching as a how interesting. How about if we use an at? Will it work? There we go. So here is go pass. So then this string some sample, I don't know, fib.dpl as this. Whoops, that should work now. So now you're telling me that if I go this right there, that does work. So embed binary. So it should be a byte. Yep, a string byte. So yeah, no. It works. Alright, it works. Good. Good. It works. So now we know that it works. Works. So yeah. Go Control N, Control S, embed file and .dpl. So here I'm just gonna go use standard text file and then there we go. So that should work, I think. So we just go embed test.txt as my file, and then here I'm just gonna go file printable and my file, my file, and then other file, no, this file, um, embed file as this file. So now here in PyParser we're gonna go in here, we're gonna define some stuff. So in frame -1 dot update what is it piece of file kernel name. Problem is how we get the name, because that's obviously not the name. So I guess it will be useful for other. So that won't work because file not found is the T. Oh, that won't work because that's not me. So here we're gonna go and just F code. So we're just gonna go F code, and then on here in embed if name args0 is equal to name. Then we don't need to open it, we just need to go F code. Yeah, that's it. And you go continue. That's it. And if it says embed as a binary, then you just need to go to bytes. Right? You just go to bytes. There we go. So that's it. So this should work now. It works. And of course, this is my finals works. Anyways, what was I doing? Oh yeah. this and stuff, and then now we just need to document all of these things, which I am too tired now. So what I want to do is to push it. There we go. Oh, the part, yeah, we should also add that modules and wrappers. Oh, this is gonna be another batteries included program now, isn't it? Nah, we're gonna leave it to the user to write their own freaking wrappers. You know what? Nah, wait. You know what would be fun if you tried to make a game. So that's, you know what, let's make a login page, Let's make a login page. Why? Because I want to. Oh, we haven't made that. Wait. Forgot about that one operator. So second. Chotomate. Uh, Oops. Why do I keep pressing them? There we go. So now, and then of course we have the not operator. We have the not operator, le operator, and of course, so that C bastards can just show you C users are not C programmers are not bastards. They made Python after all in C and C++. I hate C++. C is better. Revert to C. So now we just go hello world. So we're gonna go pause and we're gonna go here. You may now exit this program. What are you doing? Common. It's a boring game, alright? It's a boring game. A very boring one. Oh wait, I forgot we have Pi installer. So we can go desktop this and go, CMD into here. And we can go, yeah, we have that. So, add data instead of splash name, splash image name dash and name. So, which is gonna be one file and that's it. So, Pi installer dash one file. Yeah, it's gonna be a mess in it. It will just go haywire in it. Um, I installed a DPL. That's it, and then boom. Oh, that's the problem. It included pickle not. Oh no. It's gonna be a broken thing in it. And I did not do dash-1 file, so it's in building it. And there's the base library. It still uses the old icons for PYC. Yeah, where's the readme.html? Oh, it's this. Yeah, we can go delete that now. Control D. Yeah, it's gonna take a while. It's taking quite a while. Yeah, just a second. Oh, no. We need to include module. Oh, include module. Additional hooks. Copy. No collect. Hidden import module name. Okay, so find solo dash hidden import deal message hidden import Lupa. Boom. There it is. I do not see Lupa anywhere. It's going to break, yeah. Because it's supposed to be in build, not there. It is. Still not the same. Yes. Skip. There you go. Yay. Ooh. Problem is, will you be able to call the functions? So far, so good. Yes, it works. My goodness. Oh, but will it work if I deleted the core library? No, it still relies. So why? 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 So now we there's core. I just control C, control D, and yep. So this somehow. So you're going to go rename you. Is it R? How do you? Oh, it's F2. Okay. So DPL dash 1.4.6. Do that and then zip it. Zip. zip, zip. Will this work? So like I have this, right? And then for example I host it in some git repo. Can I unzip it that way? So can I like, yeah, delete that function. Then now if I go here and not that one, put WSL, WSL, that is that. And then if we go to VM box, now v, I don't know, there we go. That should work. I did not delete this, didn't I? You're gone. You're gone. No, not that one. This one. There we go. Boom. Now we're gonna go git check out to master, and we're gonna go git merge origin dash 1.4.6, and then we go push this. Don't forget to go check out. Or there we go. And now here, let's start it. I forgot I have this. I tried installing Arch and I failed multiple times. I don't know. I don't know how I failed. Yes, yeah, it's Debian. Oh no. No. Oh no. That's bad, isn't it? It's aborted. Why? Going to go start it again. You better not. Why? Don't. Arch, but let's try booting this up. Who knows? It might actually boot up. I hope. Why? Oh, we still have Debian, but Debian. No, it's referring to this Debian. I want to install Debian ISO. No, not Debian. Ubuntu ISO. It's just 5 gigs. Sure. And there it is. Oh yeah, could I have this? What if I run it? Oh, it's the 1.0. This. What if I, unpack it somewhere like here? Let's extract all. Extract. Now we have that. We have this. I can't just execute that. You can't just execute that. So why? Why? It's literally just. Yeah, I need to use. It's just. It's still. You've got to be kidding me.